let's understand the signs of trigonometric functions, in different quadrants. Imagine you have a circle, all right? So some circle, a unit circle, or you can call it, or you can say whatever it is. Fine, you have a circle. Now, say, we have a point here. Say we have a point P. From O to P, let's say you join. Okay, you join O to P. Now, see the angle what we get here, we'll call this angle as theta. Now, anti-clockwise angle is always positive. We have discussed this in the beginning. That means here, so let's call here from P, we'll take this line here, call this as Q. Now we have OPQ as one triangle, and in this case, we have triangle OPQ and angle POQ. This angle is equal to theta, correct? Remember, this is plus theta or just theta. Now in this case, what is PQ? PQ is nothing but Y, OQ is equal to X, right? And OP is equal to R. Very simple. Both X and Y are positive here, correct? First quadrant, isn't it? Now, what if I take a value in the second quadrant, some point of the second? That means, let's say here, we'll take a value somewhere over here. Okay, say I'll call this as P1. Now what we'll do, we'll take from O to P1, something like this. All right. Then again, from P1, drop a line like this. Let's call this as Q1. Now what I want you to understand is that P1 is in the second quadrant. In second quadrant, X is negative, but Y is positive, correct? That means for the second case, so what we'll do, we'll take in triangle P1OQ1, we have angle P1OQ1. This angle, this will be angle theta, but since we are taking in terms of the negative side, instead what we'll do, we'll take it in the anti-clockwise. That means what we'll do, we'll take this angle. Okay, if you take that particular angle, if I take this value as theta, okay, I'm talking about the second quadrant now. Please understand. Now in this case, angle P1OQ1, P1OQ1, but in the reflex of that. Okay, so instead of this, what we'll do, just to be a little more clearer for you, we are going to say that any point in the second quadrant, any point, the value of theta will be greater than 90 degree. Or you can also say that theta is greater than pi by 2. Correct? Now in this case, P1Q1 is nothing but Y. But what is OQ1? Minus X. Negative, right? And next, what do we have? We have OP1 is equal to R, the radius of the circle. Now what do we have? Look at the trigonometric functions. What will be sine of that angle theta? Sine theta is what? Y by R. Still positive. Correct? But what is cos theta? Cos is going to be X by R. Correct? But here, what is the value of X? It's minus X, isn't it? So shouldn't the cos be negative now? So cos theta in the second quadrant will become minus X divided by R. Minus X by R. Okay. Now tan theta. Now tan theta is what? Sin theta by cos theta. This is going to become Y by R divided by X by R with a negative sign. So what do we get? Minus Y by X. So in the second quadrant, sin is positive, tan is negative, cos is negative. That means their reciprocals will also have the same sign, isn't it? That means cosecant will be positive, secant and cot will be negative. Correct? Same logic if we use it for the third quadrant. See, for the third quadrant, what do we have? Say, assume that we have a point somewhere over here. So what we'll do, we'll take something like this and we'll take something like this. Here, both x is minus x, y is minus y. Both are negative. That means sine is negative, cos is negative, but tan will become positive. Don't you think it's minus y by minus x? Correct? That's why tan becomes positive. Okay, for the fourth quadrant. So assume that we have a point somewhere over here. So now what we'll do, so we'll take a line like this. Okay, so this is the point. Something like this. Here, x is positive, whereas y is negative. Y is negative. That means since y is negative, sine theta will be negative, cos theta will be positive, and tan theta will become negative. Now here, this particular rule of understanding, which is positive, which is negative, in which quadrant, we call it as the ASTC rule. There are many ways of remembering this. Okay, so we'll come across everything. But now, let's make a small table as to which is positive, which is negative. Alright, so let's make a small table now. So here, see, what do we have? You have the x and y. In the first quadrant, both x and y are positive, correct? So all of them are positive, A. In the second one, sine and cosecant were positive. So we'll call it as S, sine. For the next one, tan and cot were positive. So this is T. And for the last one, cosine and secant. This is C. Alright, so what we can write is A. So you can write all A. Okay, next. Students. Students. Then you can say take tea. And then finally, coffee. See, all students take coffee. ASTC. Or you can write chocolate. It's your wish. You can do whatever you want. Okay, all some of them will say all silver tea cups. This is also fine. So ASTC. Okay, so ASTC tells you which is positive in which quadrant. Okay, now to make a table of this one, so what we can write, we have the 6 trigonometric functions and we have 2 signs, correct? The first quadrant, second, third, and fourth. So here we have sine, we have cosine, tan, and the reciprocal of that. So in the first quadrant, all of them are positive, 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 positive. Second quadrant, sine is positive, cosine and tan are negative. Third quadrant, negative, negative, positive. In the fourth quadrant, negative, positive, negative. Clear? So to have all the 6 trigonometric functions and their according sign, see, this is the table. So in this table, if you look at it, the 4 quadrants, the 6 trigonometric functions. See the sign. Just remember ASTC rule, guys. Because if you know ASTC rule, you will know which is positive and which is negative in which quadrant. Very, very simple to remember. Clear? Now, this tells us that which is positive, which is negative in which quadrant. Okay. Suppose if you have a value sine of 235 degree. Now, 235 lies in which quadrant? That is very important. Correct? So, you know that it's divided into 4 parts, correct? Based on that, you can figure out it lies in the third quadrant. So, sine of that will become a negative value. Likewise, you need to first get to know, okay, which is positive, which is negative. Then we can figure out the value. Fair enough? So, now what we have here is that which is positive, which is negative in which quadrant. Okay. In the next video, what you will be seeing and what you will be discussing is about the allied angles. Allied angles in the sense how one trigonometric function is related to other and in which quadrant and what sign. So basically, these are what we call as allied angles. Okay. So in the next video, we'll discuss about allied angles.